Hello, my name is Banusha Ragunathan with my teammates Sakshi Dave and Tushar Raval. Today's presentation will be speaking about electric vehicle batteries. Lithium ion batteries are the new generation of electric vehicles commercialized by various automakers. The invention of electric vehicles as an environmentally friendly option has become favorable, replacing gas fuel vehicles. However, it has been studied that the life expectancy of EV batteries is roughly 10 years. It is composed of various toxic chemicals that cannot always be recycled. Although this technology is set out to solve environmental deterioration, it has begun to create the very same problems. This technological fix has occurred because of the engineer's ideology of progress, where batteries are automatically seen as the greener solution without weighing in on its deeper consequences. In addition, a reimagination of the design would not be easy for several stakeholders since a new shift in this tech would directly impact them. We will now move forward onto the socio-technical issues.
The EV battery was created as a replacement for polluting sources such as fuel in vehicles. Since batteries provide electricity to the vehicle, combustion does not take place and emissions aren't released. Therefore, engineers worked on this tech with the ideology that battery-powered vehicles were the way forward. However, is this really the case? EV batteries have a lifespan of roughly 10 years but are not likely to serve a purpose once dead. These batteries are full of toxic chemicals that are harmful to our environment. This can be related to Eric Schatzberg's analysis in his article about progress ideology. He gives the example of engineers preferring the use of metal over wood as the main material in the construction of airplanes. Engineers strongly supported this transition solely based on the belief that metal was the future, without continuing further research into wood options. Moreover, based on research conducted at the time, the advantages and application of metal was limited. In the same way now, battery-powered EVs are automatically seen as the way forward in greener transportation without considering the consequences that batteries will have on the environment in the future. Between 2015 and 2040, it is estimated that 4 million metric tons of lithium-ion cells will be generated. From these 4 million metric tons, 48% of the constituents will not be recycled. This shows us that the attempt to use technology to solve environmental issues only produce further polluting sources. This can be related to the topic of technological fix, since the ideology that batteries are the greener solution was used to fix the major global problem without considering the potential socio-technical problems involved. Eden Medina explores this idea in her book, Cybernetic Revolutionaires. She describes the Chilean government's attempt to solve socio-technical issues with cybernetics as a technological fix. They use this technology to solve social, financial, and economic problems in the country. However, it failed since it was an unrealistic approach to such problems. This idea can be translated to our naive battery-powered future, where our overly optimistic solution disregards much of the deeper environmental impacts and is the reason for which the environment is once again in danger. Given these circumstances, technological solutions aren't always the sole solution to our problems, to say the least.
The next major issue involved with the technology of EV batteries is finding a solution to its environmental sustainability while continuing to benefit all stakeholders in the product. Although this isn't an impossible task, it is a very difficult one, and is a reason why changes for the sake of the environment are often neglected. As mentioned previously, electric vehicles will inevitably be an important part of society in the near future. The stakeholders, defined as the groups involved in any changes to the technology, must be considered when recreating the battery design. A few of the main ones include EV manufacturing businesses, policymakers, raw resource providing nations, and not to mention the environment and health of the public. These groups will be directly affected by any changes made to EV battery technology. Therefore, the redesign must do justice to these stakeholders if it's going to continue to improve society. When designing a new product, engineers must identify the groups involved with its presence in order to evaluate the most effective approach to building the technology. For instance, the article What is Design for Social Justice describes the entire process that a group of engineers work through to achieve an effective technology for garbage collection. They started off by meeting with the people from the community to identify the groups affected by the garbage collection, in other words, the stakeholders. Then, they laid out possible solutions to redesigning the collection process based on concerns from those stakeholders and with consideration to the most vulnerable groups. Lastly, they selected the best design option and questioned it effectiveness for its stakeholders. This process as a whole is crucial to approaching the reimagination of the EV battery technology, since many groups will be drastically affected by any changes. Therefore, it must be considered if the technology is to continue contributing to society positively.
Next, we will discuss about the redesign of the electric vehicle batteries.
Several scientists have already realized the issues surrounding the technology of EV batteries and have begun researching the possibilities for its redesign. The first thing that comes to mind for recreating a more environmentally friendly battery is to adjust the unrecyclable components itself. Current battery designs make it difficult to separate the components for reuse and often contribute to environmental degradation. Irreversible joints like welds, rivets, and glues are tedious tasks for recycling processes. Electrical structural components create connections between systems and store potential energy. These components are stored within modules, isolated from external environments, and consist of different levels of connections, which make them the main source of disassembly issues. A simplified solution to these connections must be made to facilitate disassembly. Moreover, the large variability in battery architecture makes it difficult to develop an automated recycling chain. The placement, overlapping, and location of terminals and components must be standardized to allow for faster disassembly and sorting of components from battery packs. If batteries are to be more efficiently recycled, these factors are to be redesigned.
With an improved battery design, the redesign of the battery's life cycle can be majorly improved as well. Current statistics forecast that between 2015 to 2040, 0.33 to 4 million metric tons of EV battery waste could be generated. Of those battery outflows, 48% of the constituents will not be recycled. Excluding the plastic components, these materials are and will not be recovered due to economic viability. This means that the economic life cycle of this product must be profitable in order to prevent negative consequences on the environment. A proposed solution, being studied by all kinds of professionals, suggests that a circular economy, short form CE, could not only fix this problem but also encourage the reuse, recycling, and cascading of EV batteries, all while avoiding environmental degradation and benefiting stakeholders. CE is the concept where different trade-offs are made among different levels of an economic hierarchy. This allows the EV batteries to economically benefit all parts of its life cycle, making recycling, reusing, and multipurposing economically viable. According to studies, approximately 70 to 80% of a retired battery's capacity will still be intact, which means it can be reused. Although it would not be useful to an EV, it can be used for power storage options. By cascading the battery down to multiple afterlife uses, the need to produce new EV batteries is reduced and saves companies manufacturing costs. If recycling feasibility is improved by the techniques mentioned previously with battery design, then recycling can be encouraged within the CE loop, since it could allow other users to profit from used batteries. This entire process also has the potential to reduce the price of secondhand batteries, which could encourage its use as well. However, since the future price and market for batteries is difficult to predict at this point in time, this last benefit can't yet be confirmed.
The application of lithium-ion batteries in EVs has significantly changed in technology. Environmental degradation is a social-technical issue created relating to the idea of progressive ideology and technological fix. In particular, progressive ideology and technological fix surrounds engineering principles of manufacturing EV batteries to replace internal combustion engine vehicles and promoting a sustainable transportation solution. However, due to its damages towards the environment, constructing an improved design of EV batteries can carry many beneficial factors in terms of reusing and recycling, reducing the manufacturing costs, and incorporating its importance with stakeholders' network. We must take into consideration the impact of EV batteries because producing batteries initiates a huge environmental footprint. EV batteries itself produce a high amount of pollution, depletion of natural resources, and etc. If these negative effects were to continue, the environment will eventually be incapable of supporting the human life. With a new EV battery design, the consequences of the environment can be reduced, along with reserving natural resources and saving money. Overall, the future of our transportation will continue to improve by learning from our past mistakes and discovering new sustainable development opportunities while sustaining the economy.